Notice
Yes, sir.
group 17 has these elements: fluorine, chlorine, bromine, iodine, and astatine. Okay,
Yes,
they
sir.
are usually non-metals, and astatine is radioactive. Configuration is NS2, NP5. Okay,
Yes, sir.
it it has non-metallic. These have all non-metallic character, and the metallic character decreases down the group.
Yes, sir.
Next, F2 is pale yellow gas. Chlorine is
Right,
greenish yellow gas. Bromine is
right,
generally red color liquid, and iodine is
right,
black solid. Hmm.
right,
While with increase in the size of X2, physical state
right,
changes from gas to liquid and then to solid. Okay. This comes with the fact that it has more London dispersion forces. Okay. It has more London dispersion forces. Correct?
right,
Hmm. Right. Next.
right,
I2 conducts electricity to small extent in solid and liquid states. Okay. As conductivity increases, because as the temperature increases, the conductivity will increase.
right,
See, I2 can exhibit as I3 plus and I3 minus when it is in a solid state. That's how it is conducting electricity. Okay.
right,
In gaseous phase, you know, fluorine will be existing as pale yellow, like I said, greenish here. And bromine, when it is in a gaseous state, it will be reddish brown. And iodine is in violet color. Hmm.
right.
See, the colors of this, if you notice, there is a pattern. Okay. So the pattern is as it comes close to the iodine, it is becoming more violet. Okay.
Right.
Now, why that could be happening is, if you notice, when it comes to fluorine, the energy difference between HOMO orbital and the LUMO orbital is more. The HOMO orbital is this one, pi star 2px and 2py. The LUMO orbital is sigma 2pz. LUMO means
Hmm.
lowest unoccupied molecular orbital. HOMO means highest occupied molecular orbital, highest energy, lowest energy and highest energy.
Yeah.
So at the lower, when you are closer to the nucleus, the energy difference will be more. So
Right.
here, the electron which is going from lower, that is HOMO orbital, to the LUMO orbital, that might require more
Hmm.
energy. So since
Right.
it takes a larger energy, which means it is taking somewhere in the violet region or red region, okay,
Hmm.
sorry, violet region or indigo region, its color is
Hmm.
most likely to be yellowish and greenish like that. Okay.
Right.
So starting with fluorine, it will be yellow. Same goes with the chlorine, which is more yellowish green.
Green.
And then
Hmm.
as you come towards the bromine, now the color starts becoming more red because slightly you are coming down the color table. Hmm?
Hmm.
And lastly, when it comes to iodine, it is like it might
Iodine.
absorb more of yellowish and green, and that will start showing more violet color. Okay.
Purple violet. Hmm.
So the pattern is more of, as the lambda increases, energy decreases here. Okay.
Decreases. Yeah.
Electronegativity is a regular trend going down the group. Size is a regular trend going down the group. Ionization is a regular trend going down the group. The only difference
Hmm.
is in electron gain enthalpy. Electron gain enthalpy, fluorine is expected to be the highest, but because of its very small size, adding an extra electron will only cause more repulsions in it. That's
Right.
why instead of being the primary one, it will be on the second position. So chlorine is more
Hmm.
than fluorine, then bromine and iodine.
Right.
Boiling point and melting point, because they only have London forces to support, it is non-polar. So molar mass is the most impactful factor here. That's why I2 will have more melting and boiling point than bromine, chlorine, and lastly fluorine. Again, one
Right.
more small problem comes when it comes to bond dissociation enthalpy. And by
Right.
logic down the group, the bond dissociation enthalpy should decrease because iodine and iodine bond is longer, easy to break.
Right.
But between fluorine, although the bond length is smaller, the lone pair repulsions are very strong. It will have very
Hmm.
strong lone pair repulsions. And because of this strong lone pair repulsions also, it breaks more easily. Okay.
Okay.
In fact, this is the same factor that happens even with oxygen also. So oxygen also has two lone pairs, and that's the reason why sulfur sulfur bond is much stronger than oxygen oxygen bond.
Right.
Okay. And same goes with nitrogen also. Nitrogen bond is, you know, uh, weaker than phosphorus bond, single bond. While when it
Right.
comes to carbon and carbon, now that logic does not fit because now they do not have any lone pair on it. Okay.
Right.
So this is about the bond dissociation energy. Okay.
Hmm.
Next, bond length is a regular order. Fluorine is smaller than chlorine, bromine, and iodine. Oxidizing
Right.
power is also a regular order. Fluorine towards iodine, the oxidizing power decreases. In fact, this also suggests that fluorine is a strong oxidizing agent, so it can oxidize chlorine ions into chlorine, bromide ions into bromine, fluoride ions also, iodide ions also into iodine. Okay.
Right.
And next, I minus, when you react with Br2, it will convert into I2, and
Hmm.
Br2 will convert into Br minus. Hmm. And next, ClO3, when you react with I2, I2 will oxidize into KiO3, while ClO3 will convert into Cl2. Okay. And
Hmm.
see, BrO3 minus will also convert into Br2. That means it gets reduced in the presence of iodine and converts into
Right.
KiO3. So if I put everything in a perspective of the oxidizing order, this will be the correct order. That is CrO3 minus, then Cl2, then BrO3 minus, then Br2 and F2. Of course, F2 will be the highest of all. Hmm.
Hmm.
Done. Now,
Right.
notice what are all the oxidation states these elements can show. Fluorine shows only one oxidation state other than 0. Chlorine, bromine, iodine will show anything from -1 towards +7. Okay. But
Right.
alternatively, of course, there are cases where you will have +4 also and +6 also, +4 and
Hmm.
+6 also. These are rarely. Got it? Hmm.
Right.
See this. Chlorine, bromine, they both show +4 and +6 in their oxide forms only, like ClO2 and BrO2, ClO3 and BrO3. Okay.
Hmm.
And bromine does not show higher oxidation state as it's rare and known as the middle row anomaly. Yeah, bromine usually showing +7 oxidation state or +5, I mean, yeah, especially +1 oxidation state is very, very difficult. Again, this is something to do with the anomaly that happens with the fourth period elements. Okay.
Hmm. Right.
What are all the reactions you will notice here? See, general reactions with water. Fluorine, when you react with H2O, it gives HF and O2. With water, it can give HF and O3. Now, depends upon, what is getting oxidized and what is getting reduced here. See, if you take cold H2, if you take a very cold H2O, chances are ozone will be formed. If you take a normal H2O at room temperature, then it will give mostly O2. Okay. But
Hmm.
if you keep it at the normal temperature here, there will be some composition of O3. That's why it is called ozonized oxygen. Hmm.
Right.
And next, chlorine, when you add it to water, it will become HCl and HOCl. What we call it as chlorine water. It is getting disproportionated, -1 and +1. Hmm.
Right.
And HOCl on long standing will easily lose away oxygen and that will convert into O2.
Hmm.
Okay. So chlorine water behaves like bleaching agent because of its release of nascent oxygens. Okay.
Right.
Bromine water will also get disproportionated easily, but iodine does not get disproportionated. In fact, it
Hmm.
is very difficult to dissolve iodine because of its high non-polar character. Mhm.
Right.
All right. And that's why you can see the solubility order also. So this is the solubility order. Clear?
Right.
Hmm. Next, reaction with NaOH. Okay. F2,
Hmm.
when you react with NaOH, cold and dilute, NaF, F2 will convert into NaF and OF2. Okay. And
One
this on
second.
heating will convert into, this fluoride will become 2F minus and oxygen will convert into O2.
O2. ठीक है. Hmm.
And if you react with, cold and hot, this is about dilute. If you take cold and hot, then this OF2 factor does not come into picture. Directly O2 will come. Okay.
Right.
And if you take chlorine, bromine, and iodine, in all three cases, when you react with NaOH, it will become X with -1 and X with +1, because when you keep it in cold, the oxidation will stop at +1. If you keep it at hot or concentrated solution, then it will become up to +5. I mean, it will go up to +5. Okay. So
Hmm.
this is how the disproportionation will take place. Clear?
Right.
Right. Next. If you check out the reaction with the non-metals, okay, halogens usually forms halides very easily with non-metals. So may it be boron, phosphorus. In fact, excess means you can get multiple number of halogens. Sulfur can become S4 or S6. If it is with fluorine, it can become SF6. Got it?
Hmm.
S plus Cl2 will become S2Cl2, and S plus Cl2 will give SCl4, and S plus Br2 will become S2Br2. These are all, different reactions that you will notice it from sulfur. Okay.
Right.
Just a second. It reacts with metals. F2 plus M will convert into MFX. Okay, that depends upon what is
Right.
the valency factor for this one. Okay, and chlorine and bromine, right, will give you MClX or MBRX. Correct. So that's how they'll form. But this reaction is relatively slowly. And iodine, anything, any metal except the noble metals. That means silver, gold, platinum, and so on. Correct. Except for
Hmm.
that, rest all will also form iodides more easily. Clear, beta?
Right.
Hmm. Next. Oh, yeah. Right. Now let's notice this one. Hydrates. HF, HCl, HBr, and HI. HF is
Right.
greater than HCl, HBr, and HI. This is the bond dissociation energy. Okay. Of course, it
Hmm.
makes sense because the bond length is longer as you go down. And acidic strength increases down the group because it can be broken more easily, HI. And you remember
Yeah.
down the group, we usually check out always for, uh, we always notice it for, one
For.
bond dissociation energy more than electronegativity. Okay.
Hmm.
Reducing nature will also increase down the group. Thermal stability decreases. And all of them are related based on bond dissociation energy only. Clear, beta? So if that
Hmm.
makes sense. Yeah. Right. Now notice delta H of vaporization. Okay. Vaporization wise, HF will have a very strong bonding. So delta H of vaporization required. That means the energy required for that will be more. Got it?
Right.
And next, if it comes to melting point, clear, it is HI greater than HF, HBr, and HCl. And here, melting point, slightly molar mass is a dominant factor, but boiling point, HF will have a very strong hydrogen bonding. That will still be a dominating factor. Dipole moment wise, it decreases because dipole moment mainly depends upon polarity. So polarity is very high for HF. Is this point clear, beta?
Right.
Right. Okay.
Yes. Hmm.
Right. Next. If you notice HF, you know how to prepare HF. Got it. So if you see this CaF2, when you react with concentrated H2SO4, it can become HF and calcium sulfate will get precipitated here. Got it.
Right.
And HF is liquid and I mean HF in the liquid state and solid state, it does show an zigzag type of a structure. Got it.
Hmm.
It does show a zigzag type of structure. And in vapor state, okay, in vapor state, the HF is a monomeric form. In some cases, it can show dimeric form, correct? Or it can
Yeah.
have a cyclic hexameric form as well. These are all in the vapor
Cyclic.
state. Yeah, in hexameric form. That means
Oh,
F, then hydrogen, then F, like this. Then hydrogen, then F, then hydrogen, then F, like this. Okay.
okay.
Fluorine cannot be stored in a glass containers. In fact, that you know that, correct? HF, SiO2, breaking bad, SiO4 plus H2O. Got it? And SiF4 plus HF will convert into a, fluorosilicic acid.
Hmm.
HF has a unique property to form salts with fluoride. Now, this is very interesting. See, KF is a salt, HF is an acid, correct? But the hydrogen bonding between them is so strong that it will make almost this compound like a ionic molecule. K plus is
Hmm.
separated, and this together is appear like a anion. As such, it's not a hydrogen making any covalent bond. It cannot make two covalent bonds, obviously, but F minus will make a very strong hydrogen bonding from the HF. And because of this strong hydrogen bonding, it can be isolated as well. Okay. So this is the form it exists. Clear, beta?
Hmm.
And HF has more Ka value in concentrated aqueous solution. Okay. Which means its acidic strength will increase if you keep it in more concentrated solution. Why? HF on adding to water, it will release H3O plus and F minus, correct?
Hmm.
But if we have concentrated HF, that F minus will again interact with HF to convert into HF2 minus, correct? So what happens? The composition of F minus is consumed, right? So where does the reaction go? More in the forward direction. So concentration of H3O plus is increasing.
Yeah.
Clear now? So this is the K2 value. This is the K1 value. So you can see K2 is usually greater than K1 value. Okay.
Hmm.
Next, in HCl, NaCl plus concentrated H2SO4 at around 150 degrees, it will become HCl and NaHSO4. And NaCl plus NaHSO4 will convert into HCl plus Na2SO4 as the temperature increases. This is how you can prepare HCl as well. Okay. And you see, HCl is a colorless, pungent smelling gas. It will give white fumes
Right.
with ammonia. Okay. This is that white color dense fumes which you will get. It can dissolve platinum gold with concentrated HNO3. Okay. And if you have 3
Hmm.
moles to 1 mole ratio of HNO3, we call it as aqua regia. Got it? We call that as aqua
Yeah.
regia. And decomposes salts of most weak acids into gases. Okay. That is HCO3 minus and all of these, if you notice. Clear? Right?
Right.
They all will decompose in the presence of HCl and they'll start giving gases. Correct? So CO2 gas
Right.
or SO2 gas or H2S. This is all what we studied in salt analysis. Okay.
Hmm.
Next, what are the type of oxides that it can form? Fluorine, chlorine, bromine, iodine will have these oxides. OF2, O2, F2.
Yes,
Chlorine
sir.
will have these oxides. Bromine will have these oxides, and iodine will have these two oxides. Okay.
Yes, sir.
The star represents that they are paramagnetic in nature. Okay.
Okay.
If you notice I4O9, it exists as I3 plus IO3 minus. I2O4 exists as IO plus and you know IO3
IO3
minus.
minus.
Sorry. Check. So if you notice that iodine can make these ionic compounds as well. In fact, I4O9 will exist as I3 plus and IO3 minus. I2O4 exists as IO plus and IO3 minus. Okay.
Hmm.
This is a structure which you need to remember, which we learned it in redox reactions. That there are two different oxidation states of bromine here, plus 6 and plus 4. Okay.
Hmm.
And stability wise, if you notice, iodine is more stable than chlorine than bromine in an ionic form. Okay.
Hmm.
Now, oxides of chlorine are not prepared by oxidation of chlorine. Okay. That means if I take Cl2 plus O2 and you're expecting some oxides will form, that is not easy. Reason being, the delta H reaction is positive here. It is non-spontaneous. The only spontaneous reaction with chlorine is a Cl2O7 formation. Clear, beta? Rest all are found to
Yeah.
be non-spontaneous. Next, if you compare the bond angle, this we learned in chemical bonding, that Cl2O will have a larger bond angle than H2O than F2O.
Hmm.
In Cl2O, there will be a back bonding. That's where the lone pair will be involved in the empty d orbital of chlorine, increasing the bond angle.
Hmm.
Now, let's notice this oxides one by one. ClO2 oxide, when you react with water, will become HOCl, and that becomes an anhydrous of hypochlorous acid. Cl2O is an oxidizing agent. It can oxidize something as simple as ammonia to N2, and it can reduce into HCl. Second
Right.
one, ClO2. ClO2 is a yellow color gas, and it has a single electron moving around chlorine here. Okay, that means
Hmm.
this electron on oxygen will start moving towards this electron, I mean this side of the oxygen, as a you can see it like a resonating form, and sometime it appears on the chlorine part. And because this electron keeps moving across, all three positions here, it becomes difficult for it to convert into a dimer form. So that's why
Hmm.
it is not like, since it has an odd electron, it can dimerize. It's not easy. Okay, clear beta?
Right.
ClO2
Yes,
can be
sir.
isolated. Of course, it is reactive, but it does not dimerize and react. It will react with oxygen in the air. It can react with water in the,
But
it
not with
can react with
itself,
water,
dimerize.
but not with itself to form dimer. Okay.
Right.
So ClO2, when you hydrolyze, it can give two acids, HClO3 and HClO2. Both of them are mixed anhydrides. Okay. Sorry, both of them
Right.
are acids. So ClO2 is a mixed anhydride. Okay.
Hmm.
Similarly, Cl2O6, this is a red color liquid. In fact, Cl2O3 O3 comes from ClO3 getting dimerized. So
Hmm.
this will get dimerized, ClO3. In ClO3, the electron mostly stays in the chlorine form. I mean, at the uh, chlorine as a localized electron. That's why the dimerization becomes more easy for them. So it will become Cl2O6. Cl2O6 is also a mixed anhydride, which on adding it to water becomes HClO3 and HClO4. Okay. So this is the reaction given in JE, that what is the reaction of Cl2O6 with NaOH. Think this way, क्योंकि ये दोनों acids बनता है. When you react with NaOH,
That
it will
will
convert into salts, respective salts. Okay.
NaClO3 and NaClO4.
O4. Okay.
Hmm.
And lastly, Cl2O7 is a colorless liquid. Beta. Hmm. So
Right.
it is a simple anhydride of HClO4. Got it?
Right.
And HClO4, when you react with P4O10, P4O10 will be a strong dehydrating agent. So it will remove the water, converts into Cl2O7.
Hmm.
Okay. And what are the oxo acids we have? HOCl, HClO2, HClO3, and HClO4. By name, if you have +1, you use the word hypo. +3, nothing. +5, nothing. +7, per. These are the prefix that you will be using, correct? +2, +3 or us acids. +5, +7 or ic acids. Okay.
Hmm.
Acidic strength wise, if you notice, down the group, acidic strength decreases. Clear? Just if you
Right.
notice this exception here, so here we will have this exception where HClO3, HBrO3, and HiO4. If you compare these three, no, sorry, not an exception here. One factor I forgot. Reducing agent. Sorry, not here. In the reducing properties, HClO3, HBrO3, and HiO4. This is the order in which it will be. Here also, acidic strength increases as the oxidation state increases. Here it is +7, +5, +3, and +1. Okay.
Hmm.
Are they clear, beta? Okay.
Right.
Right.